In this video I'm just going to give quick hints on these questions if you're struggling to get started on any of them. If you've already completed some, feel free to skip those bits. So the first question says, Jenny lies on the beach at Piha and watches the sunset. As soon as it dips below the horizon, she stands up. She can see the sun again, but it sets 11 seconds later. Assume Jenny is 2 meters tall. Calculate the Earth's radius. Okay, so the first thing here is to note that to just kind of label the diagram, and we have a distance r here. Oops. That's the radius of the Earth, that's what we're trying to find. And she's 2 meters tall, so this hypotenuse of this triangle here is r plus 2. And now we kind of have two sides of a right triangle. The other thing we need to know is this angle here, theta. The angle relates to this time, 11 seconds, because the Earth spins 360 degrees in 24 hours. So what proportion of 24 hours is 11 seconds? Theta will be the same proportion of 360 degrees. So in other words, 11 over, what is it? 24 times 60 times 60. All that times 360 should give us theta. Okay, and then we have an angle and an expression for two sides. We should be able to use trigonometry to figure out what the value of r must be. Okay, so that's question one. Question two, you drop a bottle from the first floor of a building and it hits the ground at V. If you wanted it to hit at twice the speed, how much higher should you drop it from? Well, the key to this one is recognizing that this is the kinematic equations. So we want to relate the equation V to D, and so we would use Vf squared is equal to Vi squared plus 2AD, and we know that Vi, if we're dropping it, is 0. And so if this is D1, what must D2 be to give us 2 Vf all squared equals 2 times A times what in terms of D1? So how would this question mark compare to D1? That's what question 2 is asking. Question 3, calculate the trolley's acceleration. Well, this is an example of an F equals ma question. The tricky bit is working out what F and A are. F, the accelerating force in the system, is provided by the weight of that mass. The total mass that's being accelerated, however, is not just the trolley, it's both the dangling mass and the trolley. So that's the little conundrum you have to solve in question 3. Question 4 is a kind of tricky geometry problem. Most of you probably realize that the shape would be a circle, especially given that the second part of the question asks for a circumference. So the track that's kind of made by the two barbells as it rolls around in a circle. So we're going to have a small circle and a bigger circle, and we want the outer circumference. So we know that the difference in radius between these two is 40 centimeters because the bar is 40 centimeters long, and the bar is what separates the two weights. So we can first of all say that 2 pi r is equal to big C, and little c is equal to 2 pi r, big R, minus 40. There's a second condition here that we can impose, and that is that as it rolls, both the small weight and the big weight will complete the same number of complete revolutions by the time it's rolled a full circle. So we can say, it's like, say it takes n full revolutions of a weight for the whole bar to roll a full circle, then we can say that c is equal to n times 2 pi r weight, and little c is equal to 2 pi little r weight. So that this big R weight is the radius of the larger one, the little r is the radius of the smaller one. Okay, and we have numbers for those, so we can plug those in. So we have big C is equal to n times 40 pi, if we're working in centimeters here, and little c is equal to the same n times 2 times 10, which is 20 pi. Okay, so now we can just use the fact that we have these equations to hopefully sort out what big R is. Big R, or if we find big R, then we know big C. So we can find either big C straight away, or we can find big R. It's probably a bit of fiddly mathematics to get there, but you can do it. Okay. Question 5 says that we have a ball of mass m moving at speed v, making a head-on elastic collision. Elastic means kinetic energy is conserved and momentum, with a stationary ball of mass m. And so what I would do here is just draw a diagram. We have two balls, this of mass m and this of mass little m. This one's moving with speed v initially, and then afterwards they collide, and we have this ball moving this way with a speed negative v over 3. That's little and then we have the big ball moving off here with some unknown speed, and we want to find what the big mass is, so we'll leave that as m, and maybe we can just call this big V. Okay, so we have several unknowns here. It's all unknown really, but we want to get an expression of big M in terms of little m. So we're going to do the following. We're going to go E K total initial equals E K total final, and P total initial equals P total final. With those two conditions, if you substitute in all the expressions for all of the initial energies and all of the final energies, all of the initial momenta and all of the final momenta, you should be able to get to a place where you can eliminate everything to give big M in terms of little m. And I'm going to forewarn you that it's going to involve some simultaneous equations and substitutions and things, but that's the principle that you're going to use to approach that problem.